acceleration is defined as being equal to the change in velocity over the change in time. Okay, now I want to remind you that we had a very similar, in fact identical mathematical relationship that velocity is equal to a change in position over a change in time, which means that mathematically acceleration is related to velocity in the same way as velocity is related to position. For example, if I'm trying to find velocity, I can only find the change in velocity if I know my acceleration and the time. Just like I could only find the change in position if I knew my velocity and change in time. Okay, well, we can then take that knowledge and go graphically and think about how the acceleration versus time graph would indicate for position versus time graph. Okay, so for this first time period, the acceleration is constant, and so if this is the area, I know that the value at this time for velocity, let's say, is this much. That's the value of the area on this time acceleration versus time graph. Half that time I had half the area, a quarter that time I had quarter the area, and so that shows that I have this linearly increasing line, which should make sense because the slope is constant given by the constant value over here. The slope on a velocity versus time graph is equal to the value on an acceleration versus time graph. Okay, now for this next time interval, the area under the curve is 0. The value of acceleration is 0, therefore the slope should be 0, or I gain nothing. There's no additional area, no delta v. Okay, now in this graph, I assumed that my v at 0 is 0, so I had to assume that to be able to start from here. Had that not been 0, then knowing that my acceleration is only telling me my change in velocity, it could have started with v equals some positive value, and it would have been up here. I'm going to draw it in dotted lines because all I can tell is the change. So this, if I started at a positive value, then I would have changed from that positive value in the same way as I here changed from 0. Okay, so remember that this only allows us to determine delta v. We have to know where we start to be able to do this. Okay. Now we could have continued and now go to position. Okay, and same thing. Let's assume that x 0 equals 0. Let me go ahead and put a subscript here. v0 equals 0. So that way our position starts at 0, and our velocity is changing at a constant rate, going from 0 velocity up to a non-zero. So we've seen this before. That's going to be a parabola. Okay, and then the velocity stays constant at that value it ended with. So that means the slope, whatever the slope was right there, has to continue at a constant rate. So there's that time interval. So again, it's a smooth transition here because the velocity is transitioning from, it's the same value right below the elbow here as right on the other side. It's just as you go closer and closer to that elbow. And so the slope smoothly transitions to this straight line. Okay, so that's our position versus time graph given from our velocity versus time graph, which itself was given from our acceleration versus time graph.